Hello everyone, welcome to this lesson. In this presentation, we'll learn about the Cisco IOS command line interface, also known as the CLI. The CLI is one of the most important and basic skills in networking. Almost every network engineer uses the CLI every day to configure, to manage, monitor, and troubleshoot devices. Cisco devices such as routers and switches are usually controlled through the CLI, even though some devices also support graphical interfaces. Professional network engineers mostly prefer the CLI because it is faster, more powerful, and gives full control over the device. Cisco devices mainly use the Cisco IOS operating system. iOS stands for Internet Work Operating System. This operating system allows administrators to interact with the device through text-based commands. Using the CLI, engineers can configure interfaces, assign IP addresses, enable remote access, create VLANs, check device status, monitor traffic, and solve network problems. The CLI is also extremely important for the CCNA certification exam because many exam topics require configuration and verification commands. In real enterprise networks, engineers spend a large amount of time working in the CLI. For this reason, understanding how the CLI works is considered a fundamental networking skill. In this video, we'll study several important topics related to Cisco IOS and switch management. First, we'll learn how to access a device. There are different methods to connect to a device, including console access, telnet access, and SSH access. Each method is used in different situations and has different security levels. Next, we'll learn about console connections. This includes console cables, console ports, terminal settings, and how a PC connects directly to a device. After that, we'll compare Telnet and SSH. Both protocols allow remote access to network devices, but they work differently in terms of security. Telnet sends data as plain text, while SSH encrypts all communication. Because of this, SSH is the recommended method in production networks. We'll also study the difference between user exec mode and privileged exec mode. Cisco IOS uses different privilege levels to control what users can do on the device. User mode provides limited access, while privileged mode allows full administrative controls. Understanding these modes is very important because engineers move between them constantly during configuration and troubleshooting. Another important topic is CLI help features. Cisco IOS provides many built-in tools and help users complete commands, check syntax, recall previous command, and reduce typing mistakes. These features make the CLI easier and faster to use. Next, we'll study configuration modes and navigation. Cisco IOS contains several configuration levels such as global configuration mode, interface configuration mode, VLAN mode, and line configuration mode. We'll learn how to move between these modes and understand what each mode is used for. We'll also learn about switch memory types. Cisco switches or routers use different memory areas for different purposes, including RAM, flash, ROM, and NVRAM. Each memory type has a specific role in storing the operating system, configuration files, and temporary data files. Understanding memory types is very important because configuration files and iOS images are stored in different locations. Finally, we will learn how to save configuration and when changes are made on a Cisco device, they are first stored temporarily in RAM. If the device reloaded before saving, all changes will be lost. For this reason, network engineers must save the configuration correctly so it remains after a reboot. At the end of this video, we will understand how to access Cisco devices, how to move through the iOS CLI, how to configure and verify settings, and how Cisco switches or routers store and save information. These skills are not only important for passing the CCNA exam, but also essential for working in real-world networking environment. Cisco devices are widely used in enterprise networks. These devices run the Cisco iOS operating system. Cisco iOS is a software that allows us to configure and manage the device. To manage a Cisco device, we can use different methods. The most common method is the CLI. CLI means we type commands in order to control the device. With CLI, we can configure the device, create VLANs, manage ports, and troubleshoot network problems. CLI is widely used because it is fast, it is flexible, and it's very powerful for troubleshooting. Network engineers mostly prefer CLI in real environments. We usually access CLI using console cable, SSH remote connection, and or telnet connection, which is less secure and rarely used today. Some Cisco devices also support a web interface. This means we can open a browser and manage the device visually. This method is easier for beginners, simple for basic configuration, but it's not used much in large enterprise networks because it has limited features compared to CLI and it is slower for complex tasks. In large networks, devices are managed using special software tools. For example, Cisco DNA Center, monitoring systems, and network management platforms. These tools allow engineers to monitor many devices at the same time, receive alerts, automate configuration. So now let's talk about interface naming. Every port on a Cisco device has a name. Cisco uses names based on speed. For example, fast Ethernet means that 100 megabit per second. Gigabit Ethernet, which means 1 gigabit per second. 10 gigabit Ethernet, which means 10 gigabit per second. Today, most devices use gigabit Ethernet. Cisco use the format is X slash Y slash and Z. For example, gigabit Ethernet 1 slash 0 slash 24. This means one means device number, 0 means model or slot number, 24 means port number. So this tells us exactly where the port is located on the device. This naming system is very important in large networks because it helps engineers easily identify ports. The Cisco switches are popular enterprise as an enterprise access device. It is used in the access layer of networks. Key features: it supports layer 2, supports VLANs and tracking, and has gigabit Ethernet ports and designed for stable enterprise performance. It is commonly used in office networks, campuses, enterprise access networks. So Cisco Catalyst devices are managed mainly through CLI. CLI is the most powerful and common method Interfaces are named based on speed and the location, such as gigabit Ethernet 1/0/24. Understanding this is very important for anyone starting networking. How we access the Cisco CLI? There are three main ways to do this: console, telnet, and SSH. Let's start with the first one, which we said console connection. A console connection is a direct physical connection between your computer and the device. You use a cable for this. We usually use console access when we are setting up the device for the first time. The device doesn't have an IP address, or when we are troubleshooting problems. So basically, console is your direct emergency access to the device. So second method is telnet. Telnet allows us to access the device remotely over the network. So you don't need to be physically near the device, but there is a big problem with Telnet. It is not secure. Everything is sent in plain text, including the passwords. So, if someone captures the traffic, they can easily read it. Because of this, Telnet is not recommended anymore in modern networks. The third and most important method is SSH. SSH also gives you remote access just like Telnet, but the difference is security. SSH encrypts all communication, so passwords and commands are protected. This makes SSH the standard method in real production networks today. If you are working in a real company, you will almost always use SSH. One important point we need to remember: no matter which method you use, console, telnet, or SSH, you always land in the same place first. That's called user exec mode. This is the basic level of access on a Cisco device. From there, you can move into higher privilege modes if needed. So, console is for direct physical access. Telnet is remote but not secure. SSH is also remote, but it is secure and the recommended one, and all of them start from user exec mode. Now let's talk about console settings on Cisco devices. Cisco devices use standard console communication settings called 8N1. Let's break that down simply. The first setting is the speed, 9600 beats per second. This is the default baud rate for Cisco console connections. Next is 8-bit ASCII. This means data is sent using 8 bits for each character. Then we have no parity. Parity is a simple error checking method, but in Cisco default settings, it is not used. After that, we have one stop bit. This is just a signal that marks the end of each data packet. And finally, no hardware control, flow control. This means there is no extra control mechanism between the PC and the device. So again, the full console settings are 9600 baud, 8 data bits, no parity, one stop bit, and no flow control. Uh, Now, here is something important. If these settings are wrong, the console output will not look normal. You may see random characters or unreadable text on the screen. So, matching these settings correctly is very important. There are different types of console cables depending on the device. Newer Cisco devices usually use a USB to USB Mini B cable. This connects directly from your computer to the device. Older systems use a different type of cable. They use an RG40 5.2 dB 9 serial cable. This was common when computers had serial ports, but today most modern laptops don't have serial ports anymore. So we often need an adapter. For example, an RJ45 to USB adapter or a USB to serial converter. One important point to remember: when you use a USB console connection, your computer usually needs a driver. Without a driver, the system may not recognize the Cisco device. Let's compare Telnet and SSH. These are two methods used for remote access to Cisco devices. Let's start with Telnet. Telnet is an older remote access protocol. It is used TCP/IP to connect to a device over the network. So it allows you to manage a device or router switch without being physically there. But there is a very important problem with Telnet. It doesn't use encryption. This means all information is sent in plain text. So things like usernames, passwords, and even commands can be easily seen by anyone who is monitoring the network. Because of this, Telnet is considered unsafe for modern networks. It shouldn't be used in production environments. However, Telnet is still sometimes used in limited cases like lab environments, testing scenarios, or very old legacy systems. So basically, it is only acceptable where security is not critical. So another protocol is SSH, which we said before. It means secure shell. Secure shell is a modern and a secure replacement for Telnet. The key difference is SSH encrypts all communication between your computer and the Cisco device. This means it protects your login credentials, your commands, and all network traffics. Even if someone captures the data, they can't read it. From a user perspective, SSH works almost the same as Telnet. You connect remotely, log in, and run command. So the experience feels similar. But under the hood, SSH is much more secure. That's why in real production networks today, SSH is always the standard choice, and Telnet is generally avoided. Cisco devices have different access levels depending on what the user is allowed to do. The two most important modes are user exit mode, privileged exit mode. User exit mode is the default mode when you first connect to a Cisco device. So when you open the console, SSH, or Telnet session, you automatically land in this mode. In user exit mode, the prompt is limited. You will see a simple prompt that ends with a greater than sign. This indicates that you are in basic access mode. In this mode, you can run only basic commands. For example, show commands like checking interface status, ping to test connectivity, and other simple monitoring commands. But there is an important limitation. In user exit mode. You cannot make any configuration change. So you can't configure interfaces, change settings, or modify the device behavior. It is a read-only monitoring level access. Privileged exec mode, also called enable mode. This is the administrative level of access. The prompt here ends with a hash symbol. This symbol means you now have full control over the device. In privileged exec mode, you can do much more. For example, configure the device, restart or reload the device, access advanced troubleshooting commands, and view detailed system information. To enter this mode, we use a simple command which we name it enable. After typing this enable command, the device may ask for a password if one is configured. And if you want to go back to user exec mode, you can use disable command. This brings you back to the limited access level. The main difference between these two modes is control level. User exec mode is for basic monitoring only. Privileged exec mode is for full administration and configuration. Now let's look at some very useful Cisco iOS help features. These features make working in the CLI much easier, especially for beginners. The first and most important help feature is a question mark. In Cisco iOS, if you type a question mark, it shows you available commands. For example, if you type after show command question mark, Cisco will display all options that can be used after the show command. So it helps you understand what commands are available in that context. Another example, for example, com question mark, this will show all commands that start with com. So it works like an intelligent suggestion system inside the CLI. Another very useful feature is the type key. The type key automatically completes commands. For example, if you start typing a command and press tab, iOS will complete it for you. This is useful because it saves time, reduces typing, and helps avoid spelling mistakes. So instead of typing full commands, you can often just type a few letters and press tab button. Cisco iOS remembers your previous commands. This is called command history. It allows you to reuse commands without typing them again. There are also useful keyboard shortcuts for command history and navigation. Up arrow or Control P shows previous command. Down arrow or Control N shows next command. Left arrow or Control B moves cursor backward. Right arrow or Control F moves cursor forward, and backspace deletes characters. These shortcuts help you edit commands quickly without retyping everything. By default, Cisco iOS stores the last 10 commands in history, so you can go back and reuse the last 10 commands you entered. Cisco iOS configuration mode is very important part of this topic. Understanding these modes is very important because all device configuration happens inside them. Everything starts from enable mode, also called privileged exit mode. This is the mode where you have full administrative access. From here, we move into configuration mode. To enter configuration mode, we use the command configure terminal. After entering this command, the prompt will change and we'll see config. This means you are now in global configuration mode. In this mode, you can take system-wide change to the device, but we don't configure everything directly here. Instead, we move into more specific submodes. From global configuration mode, we can enter different submodes depending on what we want to configure. For example, if we want to configure a network mode, network port, we use interface, for example, interface gigabit Ethernet 0/1. After this command, the prompt will change to config if. This means we are now inside interface configuration mode. Here we can configure settings like IP address, speed, duplex, and port settings. If we are working with VLANs, we enter VLAN configuration mode. This is used to create or modify VLANs. Another important submode is line configuration mode. It is used for access settings like console access, SSH access, telnet access. So in this, the prompt here looks like config, line, etc. So to leave a sub mode and go one level back, we'll use exit command. This takes us step by step backward. But if we want to go directly back to enable mode, we have two options: end command or control Z command. Both commands take us immediately to the top level. There is one very important thing to remember: in Cisco iOS, configuration change take effect immediately after you press enter. There is no apply or save change button like in graphical interfaces. So once you enter a command, it is active right away. Cisco devices use different types of memory, and each one has a specific role in how the device operates. There are four main memory types: RAM, flash, ROM, and NVRAM. RAM is a working memory of the device. This is where the active configuration is stored. We call this configuration the running config. RAM is very fast, but it is not volatile memory. This means data is not permanent. So everything in RAM is lost when the device is powered off or the device is restarted or reloaded. So in simple terms, RAM is temporary memory used while the device is running. Flash is a type of permanent storage. It is used to store the Cisco iOS operating system image. So when the device starts, it loads iOS from flash. Flash memory may also store backup files or software images. Unlike RAM, flash is non-volatile, so data stays even after power loss. ROM contains a very important program called the Bootstrap program. This program runs immediately when the device is powered on. It has three main tasks. It starts the device, it initializes the hardware, and it helps load the iOS from flash. So ROM is basically responsible for the very first step of the boots process. NVRAM stores the startup configuration called the startup config. This configuration is saved permanently. So even if the device loses power, the data is not lost. That's why it is called non-volatile memory. When the device boots, ROM starts first and runs the bootstrap program. iOS is loaded from flash into memory. Then the startup config is loaded from NVRAM into RAM. After that, the startup config becomes the running config in RAM. So RAM holds the active configuration while the device is running. One very important concept to remember: startup config command is stored in MB running config is stored in RAM, and changes made during operation are stored in RAM first. Whenever you make changes on a Cisco device, those changes are first stored in RAM. This active configuration is called the running config. But there is an important point: if the device reloads or loses power before saving, all changes will be lost, because RAM is temporary memory. To make your configuration permanent, you need to save it. In order to save, your configuration from RAM to NVRAM, we'll use command copy running config startup config. This command copies the active configuration from RAM into NVRAM. So it becomes a startup config, which will be used when the device boots again. So sometimes we need to reset the device to factory-like state. For that, we can use some commands such as write erase startup config, or erase MBRAM. These commands delete the saved configuration from MBRAM. But remember, after erasing, you must reload the device. Only then the device will start with an empty configuration. Now let's quickly review some of the most important Cisco iOS commands. For example, enable enters privileged exit mode, disable returns you to user exit mode, configure a terminal enters global configuration mode, and or Control Z returns directly to enable mode. And the show running config will show us the active configuration in RAM, and show startup config will show us the saved configuration in NVRAM. We have also reload command, which means restart the device, and another command copy run start, which means saves running configuration to startup config. So the key idea to remember is running config is temporary and stored in RAM. Startup config is permanent and stored in NVRAM. So if you don't save your configuration, it will be lost after a reboot. In this lesson, we learned the basic of Cisco iOS management. We discussed different ways to access the Cisco CLI, including console, telnet, and SSH. We also learned about Cisco iOS mods, configuration modes, and important CLI commands used in daily network operations. After that, we explored Cisco device memory types such as RAM, flash, ROM, and NVRAM, and understood how configurations are saved on a device. These topics are very important because they form the foundation of Cisco networking and device management. Thank you very much, and see you in the next lesson.